Hey there, hi there, ho there. Welcome back to Unit 7, Sediments and Sedimentary Rocks. Alright, full disclosure. Sedimentary rocks and sediment is not my favorite. But these types of rocks do tell one good heck of a story. They're not my favorite because they're not much to look at in most cases. But again, sedimentary rocks do tell one heck of a good story. So, let's get into it. So, what am I talking about? So, sediment is broken down material from existing rocks, and it's classified by size, not chemical makeup, not mineral makeup. So, sediment, there's different classifications we'll get into. It's broken up by size. So, that's what sediment is, broken off pieces of existing rocks, and depending on the size, we'll call it different sediments. Again, just based on the size of the material. You take that material, you compact it together, you cement it together, and you get sedimentary rocks. So sediment, sedimentary rocks. So in order to get the process going, to create sediment, we first need to break down existing rocks. So whatever rocks are around, typically at the surface, whether it's igneous, metamorphic, or other sedimentary rocks, we have to break those down because we need to break them off into little pieces. So what in nature could cause a rock to break? That's what we're going to kind of start off first. So what could cause in nature rocks to break? To crack like this, so this looks like a statue that's really been, it was almost decomposed almost, or melted. It's not really melted, but something's breaking this down. So what causes rocks to do this? Well, let's jump back over to the rock cycle. So last unit we talked about volcanism and igneous rocks. And then, again, typically in a geology class, you learn igneous rocks, sedimentary rocks, metamorphic rocks. But it can go any which way. All right, but let's say now we have some igneous rocks. And now they're going to undergo the process called weathering. And weathering occurs due to the interaction of solar energy and water, the water cycle. So the interaction of solar energy and water, so we're talking actual weather processes, can create weathering. Rocks to break down into sediment, and then with heat and pressure, a little bit of heat, a little bit of pressure and cementation, you get sedimentary rocks. So what causes rocks to break down is the interaction of the sun and the water cycle, which we know as weather. Hence weathering. So there's a difference between these terms, weathering and erosion. Oftentimes, people use the term erosion meaning both of these things, but technically it's not. So we have an existing rock. Weathering is the breaking down of that rock, whether by chemical means or physical means. We're breaking down a rock into small pieces. So that's what weathering is, breaking it down into smaller pieces. Now that we have these smaller pieces, erosion is the transportation of these little pieces of sediment, these particles of rock. And it can move downhill due to gravity, air, flowing water, ice as glaciers flow and move can bring sediment with it. So they work together, but they're not the same thing. Again, people, I think, just use the term erosion, and they kind of mean both of these. But erosion just means the movement. The breaking down is called weathering. If you kind of think of it like if I wanted to break down some rock and move it somewhere else, weathering is like the hammer action, breaking it down. I took a big hammer, just started hitting a rock to break pieces off. Erosion is like if I put that material on a truck and transported it from A to B. To give you a little visual, again, weathering is the breaking down of the rock. Erosion is the transportation, whether that's by gravity, air, wind, ice, what have you. So let's focus on the breaking down of rocks. That's what we need to start to create sediments. So sediments are created as rocks are weathered, as pieces are broken off. And so with weathering, there's actually two types of weathering. The first is mechanical weathering. This is the breaking down of rock into fragments by a physical process. Something is physically interacting with this rock in order to break it down. And when this rock is broken into pieces, the chemical composition of the rock is not changed. So if I take, like this chunk of granite, and I hit it with a hammer, and the pieces that fall off are still going to be granite, meaning the chemical composition has not changed. So here's granite. I just start breaking it down. The pieces that are coming off those, it's still granite. So that's mechanical weathering, because I would physically be attacking this thing. Let's see here. What do I got? Okay. I got hammers. I got a hammer somewhere. Well, I used to have a hammer somewhere. Anyway. So again, if I just took this screwdriver and just start attacking this thing, all these little pieces that are coming off are still granite. All right, I'm physically weathering. That's mechanical weathering. Now, as this naturally occurs, there's 4 different main types of mechanical weathering. Sheet jointing, or also known as exfoliation, frost wedging, root wedging, and salt wedging. And we'll kind of go through each of these. So if you know what this person is doing, then you know what the term might allude to. So this person, I don't know, I've never done this. This is outside my realm. But I'm assuming this person puts some sort of stuff on their face to peel off to help exfoliate their skin, to peel this stuff off to reveal new layers. Well, the same thing happens in rocks, and it's a type of mechanical weathering called sheet jointing, sometimes known as exfoliation. As rocks heat up from the sun, all right, as the sun heats up a rock, as anything heats up, it actually expands. So when a rock is heated up, it expands, and then at nighttime the sun goes away, it cools and shrinks. That happens again the next day. Heats up, expands, at nighttime it cools off, shrinks. So that process of heating and expanding, even at a small millimeter level, can start to break and flake off chunks of rock. So that's a physical process that the rock is going under. And so some rocks will start to flake off. Like you can see all these layers are just flaking off. That's sheet jointing or exfoliation. This is Half Dome in Yosemite, and there's typically a line to get to the top. And that's why you'll never see me in Yosemite. I don't like to wait to climb things. So anyway, so that's one mechanical weathering style, sheet jointing or exfoliation. Another one is what's happened here. So soda pop. So have you ever done this? Taking a can of soda pop or some beverage, you throw it in the freezer because you want to cool it down real quick. And you're going to take it out in like 10 minutes, but then you just forget about it. And like a couple of days later, you find it and the can is all kind of, pushed out or sometimes even exploded. That's because it contains a lot of water, and water does something very, very weird. Water is a very weird substance. Most substances, when it heats up, it expands, and when it cools down, it shrinks. Well, water kind of does that, but there's a temperature range. As water is getting cooler and turning to ice, it should get smaller in volume. It should get less or more dense, more compact. But at some point, it actually starts to expand a little bit, and ice is actually less dense than liquid water. So it expands. It has to deal with some molecular makeup and how the molecules of water interact and rearrange themselves as they freeze. But water is weird, and then so when it freezes, it actually expands, becomes less dense. So that's why when you throw something in the freezer, like a drink, it expands because most of it is water content. And water, when it freezes, expands. So that's what's going on with this can of soda pop. Well, that is also what can cause a mechanical weathering process in rocks, and it's called frost wedging. So let's say there's even a teeny tiny little crack in a rock, and you get one little water droplet in there. Maybe at night that water droplet freezes and turns to ice, and again, ice expands. All right, and then in the morning time, it would melt, turn back to water. And then at nighttime, it'd freeze again. Maybe it pushes it out a little bit more, so more water can get in. In the daytime, liquid water shrinks. So that process of the water freezing and expanding and then melting and contracting is kind of just applying more and more and more pressure. The more water you can get into these little cracks, they can form big cracks. And at some point, frost wedging can just crack a whole rock right into. This is a big chunk of granite, very strong igneous rock, and so this slice right down the middle comes from over time, just ice just expanding and expanding and expanding, and then at some point, crack the whole thing right open. So water trapped in cracks freezes and expands, crack a rock right open like an egg. So that's a physical process. Root wedging is another mechanical weathering style in which instead of like water expanding as it freezes, you get roots of plants that, either kind of grow into cracks and rocks, or maybe a seed fell in a crack and started to grow. And as those roots grow, they kind of serve that same purpose. And as those roots expand, they'll crack and break rocks. And then there's salt wedging. It's somewhat similar to frost wedging. But if you look in the background here, you can see a key to this type of mechanical weathering. So back here you have the ocean, which is salt water. So imagine as waves or wind sometimes picks up ocean water and deposits it on the rocks nearby. Well, as the water part evaporates, it leaves behind the salt. And then let's say some more ocean water gets sprayed into these holes. The water evaporates, but it leaves behind the salt. And as the salt accumulates, it kind of starts to grow together to form salt crystals. So these salt crystals begin to grow and expand. And as that happens, the salt crystals, as they're expanding, kind of slowly expand and break away the rocks. And you can kind of get this honeycomb pattern, and that's due to salt wedging, which is very similar, again, to, what the heck did we say? Frost wedging. So those are all mechanical weathering means. Something is physically causing the rock to break down, right? Water is causing it to break down. Salt is causing it to break off. Roots are causing it to break off. Itself, as it's expanding, is causing it to break off. So that's all physically done to these rocks to break it down into pieces, into sediment. So we have physical, mechanical weathering, and then we have chemical weathering. And we're going to pause here, and when we come back, I'll take you through chemical weathering. See you back here in just a second.